So let's start. Hi everybody, welcome to my session today. Systems integration in the cloud era with Apache Camel. Before I start the session, I want to introduce myself shortly. My name is Kai Wähner. I work for Mayborn Wolf et al. That's a small IT consulting and software development company in Germany. And in the main time of my task, I do consulting and developing, especially in the Java environment. Besides, I do some talks at conferences and write articles for journals. If you have any feedback for the session, please write me an email or contact me via Twitter or via a social network, LinkedIn. I appreciate every feedback. Okay, I want to start with an introduction why I'm doing this talk today. And the reason is the growth everywhere in every company where we are for our customers. There are always more and more applications, you have more and more interfaces and technologies, and the number of products increase a lot. And combined with this, you also have a new paradigm ahead. So in the past we had client-server, which we used for applications. Then 10 years ago we started with the service-oriented architectures. And now since 2 or 3 years we're starting with cloud computing. And so this new paradigm in cloud computing also has to be integrated, of course. It has to communicate with other services, with other cloud services, but also with legacy applications. And so in the end, we have to integrate all these cloud services. The problem is all roads lead to Rome in the end. You can write a lot of glue code every time and integrate your applications and reinvent the wheel every time. And of course, that's not really a good solution. It's a lot of efforts every time. And so there are some wishes for system integrators. These wishes are first standardized modeling, all integration problems. And then when we have our problems modeled, then we of course want to integrate them efficiently. This means without a lot of boilerplate code and so on. And finally, and that's probably often the toughest task, is to also automatically test these integration problems. So we don't want to do it only by hand, we want to do it automatically via unit tests. And if you have ever integrated several different technologies in the past, you know how hard this can be if you don't use the right tooling. So this was a short introduction why I'm doing this talk, and now I will show you how you can integrate your cloud services with Apache Camel. And therefore today I have 3 key messages which I hope you will keep at the end of the session. The first key message is the cloud already arrived, definitely, and it must be integrated. Your cloud services have to communicate with all your other applications and services. Then the second message is the cloud integration is already possible, and Apache Camel helps a lot, as you will see in this talk today. I will also show a lot of live demos, so you will see it's really easy to integrate cloud services with Apache Camel. So let's look at the agenda shortly. First I will start with an introduction to cloud computing. No worries, only 1 or 2 slides. Then I will introduce Apache Camel to you. So who of you already knows Apache Camel? So okay, it's about 30% or so. So I will about 10 minutes or so take to explain Apache Camel. And then I will go on and integrate different cloud services with Camel. And I will explain several different examples. And finally, I will show you how to create custom cloud components if there's no one available within Camel. Okay, so we start with an introduction to cloud computing. As I said, only 2 slides, no worries. Just to have the same understanding of what we are talking in this session about. And if you take a look at the slide here, you have several different alternatives for deploying applications. On the left side, there's the on-premise alternative, so you host the applications in your environment, on your machines. And then you have different alternatives for cloud deployment. In the middle, you have infrastructure as a server. And as you can see here, you have full control over the application which you develop, but you don't even have full control over the VM which you use. So that's a huge difference to on-premise solutions. And then you can also use a platform as a service solution. There you don't even have full control over your app which you develop. And finally, you can use software as a service. There you don't have any control, you just use the service. I just wanted to use this definition though that we are all talking about the same when I say cloud computing or infrastructure as a service or so. And probably, as you know, every vendor in the meantime has cloud products available, so the cloud definitely has arrived and must be integrated. So let's now come to Apache Camel. What is Apache Camel? And Apache Camel is an integration framework. So to explain you what exactly is an integration framework, I have a small graphic here, and you can see on the left, this is just an API. So if you have an integration problem and have, for example, to use just one cloud service, then you can use the API of that service. For example, if you use Amazon Web Services, you can use the Java API or the .NET API or the Ruby API to communicate to this cloud service. So, but if you have several different technologies which you want to integrate, then you should use an integration framework, because an integration framework is exactly built for this problem, and it helps you a lot. It reduces the efforts for you a lot, as you will see today. And on the right we have the Enterprise Service Bus. This is the powerful integration product. The difference to the integration framework is that you have much more capabilities. You cannot just integrate your different technologies and applications. You can also do business process management and business activity monitoring, and you have a rules engine and all that stuff. So if you need all of that power, then you can use an Enterprise Service Bus. But if you want just integrate your technologies and applications, an integration framework is the best solution, because it's not that powerful and not that complex, therefore. And if you look at integration frameworks in the Java environment, you have three alternatives. These alternatives are Apache Camel, Spring Integration, and Mule. All of them are open source, and all of them have the same capabilities. In the end, the goal is to integrate your applications and your technologies and services. It's not about in this talk about the difference of all of these, so I've written a blog. You will get the slides later. You maybe want to read this blog about the differences. To sum up shortly, my favorite is Apache Camel for several reasons. First, it has the largest community of all of these three. Then it has the most connectors, and it has the best domain-specific languages. And as we will see later, it is really easy to use, and in my opinion, it's the best framework. But of course, you read this blog and look at the other one too, so all of three of them can be used for integrating different applications. But today, we will talk about Apache Camel. And so, what now is Apache Camel? It's an integration framework, and this integration framework implements the enterprise integration patterns. So, enterprise integration patterns, that's a book here by Gregor Hopi and Bobby Wolf. And this is the de facto standard for modeling integration problems. So when you have a large integration problems, you can divide it into many small parts, and then you can solve each of this problem in its own and combine the solutions, as you will see here. And the great thing about Apache Camel is that Apache Camel implements these enterprise integration patterns. So for every simple small solution, you have one method in Apache Camel which you can call to do it. So you can see here, for example, there are several of these enterprise integration patterns. There's, for example, a splitter, and there's a translator, and there's a content-based router. Probably you have heard many of these patterns. And you can use them to divide, to use your complex problem, integration problem, and divide it into many smaller parts, as you can see here in this example. So here we are using a file directory as input, and we read these CSV files, and then we do transform them, and then we split them, and then we use a content-based router to send the messages to an endpoint depending on the content of this message. And probably also, if you have never seen these patterns before, you really can understand what is happening here. It's really easy to understand, and it's a good visualization of your integration problem, and it's divided into many smaller parts. And as I said, Apache Camel implements these patterns. So as you will see in the demos now, for every of these patterns, you have one method in Apache Camel which you can call. And this is the reduction of boilerplate code, because Apache Camel helps you here and reduces the efforts a lot, because you don't have to write this. You just care about your integration logic, but not about what's behind these in these patterns. Let's now shortly talk about the architecture of Apache Camel. Let's look on the left first. So here you have your domain-specific language. For your integration logic, this is called a root in Camel. And here you write your integration logic and the processing of it. So you always have a from endpoint, where is your message coming, and you have two endpoints, where do you want to send it. And in the middle you can also do integration logic for some processing, for example routing, transformation, enrichment, transformation and that stuff. And this is the second component. And the third important component of Apache Camel are the endpoints and components, or in other frameworks it's also called connectors, which in my opinion is the better word connector, but here it's a component. So you have a component for every different technology you want to integrate. For example, here we see JMS and HTTP and file, and there are about 120 other components available. And the great thing about Apache Camel is that you have always the same syntax in your code for your integration problems, no matter which technology you want to integrate. So as you see here we use the file endpoint, and we use the JMS endpoint and the HTTP and SMTP. And it does not matter which endpoint you use. You always have this syntax for your root, and all the implementation under the hood is done by Apache Camel. You don't have to care about that. So it's really that easy to integrate your different technologies, always the same way. And as you will see later, unit testing is the same concept. So you also write unit testing with these concepts and always the same way. So what's also great about Apache Camel is that it has many different domain-specific languages. So in my examples today, I will use the Java DSL and the Scala DSL, but you can also use XML or Groovy, or even a Kotlin DSL is in the meantime available. And this is one of the advantages compared to other integration frameworks such as Spring Integration or Mule. In Spring Integration and Mule, you only have an XML DSL. So I don't like it that much because I like the programming DSLs, because you can better use them in your IDE with code completion and refactoring and so on. But also you can decide by yourself. Enough people also use the XML DSL in Apache Camel. And as I mentioned, you have several different components available already, about 120 in the moment. And you can also create your own components easily, as I will show you in the end of the session. Apache Camel can also deploy it everywhere on the Java platform. So it doesn't matter if you use a standalone application, as I will use today in the demos. You can also deploy it on every web container like Tomcat or Jetty. You can deploy it on an application server like WebSphere, WebLogic, Glassfish, and so on. You can use it in combination with a Spring container or with OSGI, and you can also deploy Camel in the cloud if you want. And finally, Apache Camel is definitely enterprise ready. Also, it's an open source product. Not all open source products are really enterprise ready, but Camel definitely is. It's about 5 years old now, and it offers all features you need in your enterprise projects like scalability, error handling, transactions, monitoring, and it also offers tooling and commercial support by different vendors. And that's also an important fact for an open source framework. There's not just one vendor behind it, such as for Spring Integration and Mule. There are different vendors which implement tooling and offer commercial support for Camel. So you do not depend on one vendor if you choose Apache Camel. So now I want to show you a little example of Apache Camel in action before we get over to the cloud integration. So I will first show you here my root. So this is a relatively simple root. As from endpoint, we use a file. So we read files from this directory. And then we do some custom processing. Here you can implement whatever you want. I will show you the code in a minute. Then we use the unmarshal component to read CSV files out to convert them to objects. And then we split them. So as you can see here, these are these enterprise integration patterns. Each one is one method. So after we have split them, so one incoming order can contain several different order items, and we split them. So every order item is one message since here, and now we log it and do a content-based router pattern. So it depends on the content now where we send this item. So if it contains DVD, I send it to this directory. If it contains CD, I send it to this directory. And if it is something else, I send it to a mock. A mock is just another component, such as file or JMS or the cloud components we will use later. So this is my root. And as I've mentioned, you can either use enterprise integration patterns which are already available, Or you can, of course, implement your own custom integration logic, for example, for transformation or enrichment or whatever. And I have two examples here. The first one is a logging processor. Here you implement a Camel interface, so you can access the exchange. The exchange of the message in Camel has the message input and meta information and so on, and you can easily access this input. So here you can see in this logging processor, I just log the message. But you can do any custom integration here. You can call a web services, call an EJB, whatever you want, it doesn't matter. You can call everything within here, it's your code. And this is one example, and then you can also use beans. The difference of beans to a processor is that a bean does not depend on Apache Camel. So as a bean, you can use every pojo which maybe already exists. For example, if you have already Spring beans, which are pojos, you can integrate them here using this bean. And here again, you can also write every custom integration logic you want, call EJBs, web services, and so on. And this is the root. And I've also written a test for this root. So that is again one of the great features of Camel, that you can unit test all of your integration logic with the same concepts. You just have to extend Camel test support. This extends from JUnit, so it's all JUnit concepts plus some advanced features added. So what are we doing here? We're using the template producer. This is a feature of Apache Camel, and send a message to an endpoint. So remember, this here is the endpoint which we use in the root as incoming root. Here we have our file orders inbox. And what we are doing in our test, we are sending a file to this endpoint with a body of a message. So this is the message we sent there. And so we create a file there. All right, so, and again here, it doesn't matter if you use a file or if you use JMS or whatever technology. It's always this syntax to send a message to that endpoint. So you can use it for all your integration tests. And then we use a mock endpoint, which is also a part of Apache Camel, to create this mock here. Again, the mock is this one. And then we can do assertions if messages arrive to this mock and so on. So here, for example, we say we expect one message because the mock receives all messages which are not DVDs and CDs. And as we can see here, we have a CD, a DVD, a book, and a CD. So only the book will be received at the mock. And finally, we also check if the file was created for orders outbox DVD. Because, remember again here, if some order items contain a DVD, we send it to this directory. And so here, we check if it is created and if it has the correct content. And then we do some setup before. I won't talk about this here. So that's a simple Camel test case. And you can use this for every technology and every Camel component in this way. And now let's run it. So we will see the screen. The unit test also starts a Camel context, which is also used in your running application. So this test simulates running Camel context, Camel runtime. And here, if we would look at the log, you can also see some of the logic which I've implemented. For example, this one is the logging processor, which I've implemented here. So as you can see, the test screen, everything works. So the file was created, all content is correct. And so you can see that this integration root works and does exactly what we want. So this was just a simple example for Apache Camel. And I hope you can get a feeling about it, how you integrate applications with it. So let's get back to the slides. And let's now integrate some of these cloud services. First, we come to infrastructure as a service. Here's an example. I've chosen Amazon Web Services. And again, remember, infrastructure as a service. You don't even have full control about your VM because you use the ones from Amazon, but you have full control about the app which you develop. There are several different providers in the meantime. We use Amazon Web Services here. And Amazon Web Services has different APIs for Java, for .NET, Python, and so on. And it's as every other infrastructure as a service provider, it offers especially services for computing and for storing in the cloud. So these are the two main reasons why we use infrastructure as a service. If you look, for example, at the Amazon Web Services Java API, In this example, we use the S3 service, so the S3 simple storage service. This is just a NoSQL key value store in the cloud. And this is the Java API. It's not really complex, but the problem is this is glue code which you have to write every time when you want to integrate an application and combine it with Amazon. And of course, we don't want to write this glue code all the time, and so we use Apache Camel to integrate Amazon Web Services with all our other technologies. And here are 2 examples how we do this. It's the same concept as with every technology, as I mentioned, no matter if JMS, HTTP, or here Amazon Web Services. At first, we use a producer. Producer means we send something to Amazon and store something in the cloud. So it does not matter where we start, where our message comes from. This is a direct endpoint. This means it's a synchronous call in Apache Camel. But here you can also use file, JMS, and all other components. Then we use this message and send it to Amazon into a bucket. Bucket is an Amazon-specific name or concept with my access key and secret key. And later, if I want, I can, of course, also read my data back from Amazon. And here I use the endpoint of Amazon in the from root. And it's always the same. And then I can send it anywhere else. In this case, I use a log component just to log it. I have a demo for this too. First, I want to show you the Amazon dashboard. Let's refresh it. So as you can see here, there's no bucket at the moment. A bucket is a storage object where you can store your data and files inside. So now we will go to the code. So until now I used the Java DSL, as you have seen here. Now I will use the Scala DSL, but it doesn't matter in the end. It looks almost the same. So it's no problem for you to understand because it's very easy routes. So here again we start with the producer route. You have seen it on the slide, so I don't have to say anything about it. This is my camel route. And then I have a test for it. So this is my test, it's also in Scala. But again here, if you have not used Scala before, you can call all of your Java APIs. And as you see here, it's almost the same syntax. You use the template producer and send a message to our consumer endpoint, which is this one. And we have sent this message, and then here I use the Amazon API to check if the message was really stored in the Amazon cloud. So it's just some simple storing here, and now I check the content and do some assertions. You write your tests as you write in other applications with JUnit. So let's run this test. And as you see, the test is green, and we can also look back to our Amazon application, our Amazon dashboard. And as you can see, here is our bucket. The bucket is the one which we define in our route. If it's not already existing, it's automatically created. And here we see the content. This is the content which we have sent in our message here. Where's the send body, exactly current date. And now let's open the text. Okay, and here's our content which we have sent. So this works. Here, of course, we use just simple text and string. Because it's a key value data store, a NoSQL data store at Amazon, you can store whatever you want here. But for simplicity, I use only some text here. And then it's the same for consuming again. So as you can see here, here we use a from endpoint. We read from our bucket and send it to a file and to a mock. And as you can see here, it's commented out here, but you can also use it for, here example, Amazon SQS, which is a queuing service of Amazon, and any other service. It's always the same. You have just to change the component, and of course any configuration if it differs. And I've written also a test here. It's no surprise. So as you can see here, again I create a mock. and then I check if the file is read correctly. And what I also check if the size at Amazon is 0. This is because by default, if you read data from Amazon, it is removed from the data store here. Of course, via configuration, you can change this. So let's run this test. Okay, and the test is green. Let's go back to Amazon dashboard, refresh. And as you can see, it is removed here. So as you can see, it's really easy to connect to Amazon Cloud via Apache Camel from any other technology. So let's continue with Platform as a Service. Here I choose Google App Engine. Let's remember, Platform as a Service, you don't even have full control over your app. So no full control over VM, and you have no full control over your app. And also in the Java environment, many different providers are available already. I have chosen Google App Engine because it was the first one and is probably the most stable one. Platform as a Service has the advantages that you can easily deploy it and you have automatic scaling. So you don't have to start your instances by yourself as you have with Infrastructure as a Service. So with Amazon Web Services, you have to start your instances by yourself. And here it's automatically done via your provider. And you of course have several restrictions. The ones with Google App Engine are really high. You have a GRE class whitelist. You have many workarounds. So it's really, honestly, it's really ugly to develop for Google App Engine. So, but nevertheless, you have your services like pushing queue, you have queuing, you have mailing, images, you can store your data there too, and some other features. And as I mentioned, here's a hint, Google App Engine is the most complex scenario for Platform as a Service. If you want to use OpenShift or Heroku or any other platform, it's much easier to integrate because you can easily communicate with these solutions. So again, here's an example of the API of the Google App Engine. We don't have to understand the content really here, but it's again some glue code. Google App Engine uses servlets here. And here we write some code to do some queuing on Google App Engine. And as integration demo, here I have chosen an example of a weather report which is already deployed to the Camel tutorials. You can also look at it and use it. And as you can see in the middle, this is an example where Camel is really deployed in the cloud. So this is what I mentioned in the beginning, that you can use Camel in a standalone application, in a web container, or even in the cloud. So here the Camel is running in the cloud application. And what we are doing, we are just calling from a web interface or programmatically this endpoint here, and then there's some work done, and we get an answer with the weather as email. So this is the code for the route. This is a little bit more complex route. So you see here, you use this HTTP is a Google App Engine component, and also the G-task. So here some tasks are done within the Google App Engine, and this is the Camel route for it. I want to show you this shortly as a demo too. So we're doing two things in this route. First, we have to, oh, is this the test on the route? So we have two routes here. The first route is for the login. We have to log in once first. I can show you the web application. You can, here we can use the web application to use this Camel application in the cloud, but we can also do it programmatically because with Apache Camel to integrate with other applications, as we will do here. And therefore we have to do a login first, programmatically. So here we do our login. And then when we are logged in, we can send any other request to this cloud service to get weather information for our city which we enter. And as you can see here, it's first our login with user and password. Then we get our cookie after login. And here's the template with the request for the weather service. As city, we use Munich. And then we send it to this endpoint here. So this is a simple example how you can communicate to the Google App Engine. So it doesn't really differ, as you see for Amazon. You use some endpoints. So I'm sorry if it is boring with the time, but it's really the great thing about Camel that it's that easy that you can integrate every technology with the same concepts. So we can switch over to software as a service. Software as a service with Salesforce. Remember again, software as a service. You don't have any control over your app. You just use it and probably pay for it. There are also so many vendors in the meantime. I use Salesforce here. It's one of the most prominent vendors for platform as a service. It's a customer relationship management for sales, service, and so on. It depends on Java, but the development is really strange if you've ever used it. It uses Apex. It's a language which is 95% similar to Java, but it is not Java. And I don't know why they didn't use Java. And if you develop it in Eclipse, of course. And what's really nice, it's not really nice, but it's so if you compile your code, you compile it in the cloud. So that's no joke. You cannot compile in Eclipse on your local machine. You always have to deploy your code on the cloud to compile it. I've never done this before, but okay. It doesn't matter for the integration problems. So here again, we have some Java API. Again, some glue code we would have to write every time again. And we again can use Apache Camel here. So this is the last time. So once again, concept always the same, no matter what you want to integrate. As you see now, it doesn't matter if you want to integrate infrastructure as a service or platform as a service or software as a service. It's always the same. You enter your endpoint here of your component, and then you enter your URI, and that's it. You can consume from everywhere you want and send it to Salesforce, and you can use Salesforce and read your data and send it again wherever you want. I have a demo for this too. Let's look first at Salesforce, the website. So this is a development edition of Salesforce, but a paid version looks almost the same. So here at the moment we have no articles. And sorry. And now close on. Here we have our producer test. So in this test case, I have entered the root directly into the test. That's also possible. And here you see, as you have seen in the slides, you can send data to Apache Camel. Here in this case, we use another enterprise integration pattern, the recipient list, because the URI is a little bit more complex, because we have to use the body of the content here with this expression language. Though it's an advanced feature of Apache Camel. But nevertheless, in the end, we read data from anywhere and send it to Apache Camel. So the test was successful, and now we look back at the website. Let's do a refresh. Okay, I just wanted to create one. I have not deleted one when trying out it before the session. So here's our created article. The time is wrong because I have a German time zone, but it was now, a minute ago. And now, as you can see, you have created it. And we can, of course, again also consume it. So from Salesforce and send it to a mock. So let's do that also. And as you can see, you received one message because there's exactly one article here. So this works too. So now I have shown you several examples of integrating cloud services with Apache Camel. And as you have seen, it's really easy, and the great thing is it's always the same concepts, including unit testing. There's now one more problem. Of course, Apache Camel does not have a cloud component or a component for every technology, every product now. So sometimes you have to create your own custom cloud components. And the good news is that it's really, really easy with Apache Camel. And it's also easier as with Spring integration or Mule, so that's another benefit. So how do you start here? You always create an archetype usually, and Maven archetype, which creates a skeleton for you. And then you again have to implement your integration logic once, and then you can use this component in your integration problems. You have 4 classes to implement. It's really just 4 classes. It's a component, it's an endpoint, and a consumer and producer. And I will show you this in the code too, and you will see how easy it is. And maybe you guessed it, because there is no Salesforce component available yet for Apache Camel, so this is a component I have implemented by myself. And it's really easy, so I will show you the code. Again, here are it's just 4 classes. The configuration class is optional because I exported some stuff here in this class, but here's the component. Or I will open all the component first. So here you have general information. Here you define how your route should look like, right? And here, for example, I say that you have to enter a custom object. In this case, custom object is a Salesforce specific name. And I say in this case, you have to use article _ C. That's exactly what I have here. So this is custom Salesforce logic. And then I do some if conditions checking, and then I'm going to the endpoint. At the endpoint, I implement some stuff which is important for both the consumer and the producer. Of course, for example, here it's to create a connection. So we have to log into Salesforce, set username and password, and implement that here. So this is the glue code which you write once, and then you can use it, as you write it once, and then you can use it in your camel routes all the time. Here I use the endpoint, and then I have the producer. The producer also has some Salesforce specific code to put data in the cloud, and the consumer is the same. Here you use the Salesforce specific query language to read data from the cloud. And I have implemented here once, as you can see. And now let's go back to the root, which I have shown you before. So these 4 classes I had to implement once. And then you can really use Salesforce, this component, in every of your projects and wherever you need it. So a lot of reduced efforts, in my opinion, and it's really a great and easy alternative. Okay, so there's also another good alternative. Maybe you just have to integrate a specific service only 1 time or 2 times, and you don't want to create your custom component. Then you can, of course, use other interfaces. So cloud services usually, in the meantime, all cloud services offer a REST service. Some also offer a SOAP service, but most use only REST at a time. For example, Amazon Web Services has already deprecated its SOAP services and only offers REST services. And you can also use these in Apache Camel really easily, as we can see here. So here we have again a from route, and want to send data to Salesforce, and here we can use the HTTPS component. This is a simple way to use HTTPS and REST within a Camel route. So you don't even need another HTTP client in Java, which you use, YAX-RS or whatever. It's again an implementation of a component within Camel. You don't have to write any glue code. You just do here your REST call, and you can read data and write data as you can do with REST. So, and again here you could use every technology here or here. It's all the same concepts also with REST. I have again one more demo. It's the last demo for today. So here's the root. I think it's the same as you see in the slide, so I won't go through it. And you have your test. And again, as you see, everything I integrate, I always test it with unit tests. And I recommend you should do this too, because it's really easy with Camel, and automatic tests, also for integration problems, are really the best solution in my opinion. And here we have two tests. The first one puts some data into the cloud. In this case, I use JSON here. So I write the JSON by my own. And then we read the data again. And here I use JSON, the Java library. So you can do whatever you want. In the end, it's important that you send JSON message here to this endpoint so that it is executed. And as you see, it's always the same. You do some assertions with JUnit, and that's it. So let's run this last test too. Okay, it's an assertion error. Maybe I have created too many articles here. I don't know yet, but I don't want to bore you here. As you see, usually it works. I don't want to try to fix it now. Okay, so I've shown you a lot of different examples how you can integrate cloud services. And so finally, I hope you did get the key messages. Let's recap that again. The cloud already arrived, definitely. Probably most of you will use cloud services in the next years. And it has to be integrated. It has to communicate with other cloud services and also with legacy applications. This integration, as you have seen, is already possible, and Apache Camel really helps a lot. And the main message here is the most important thing about Camel is that it's always the same concepts, no matter which technologies or cloud services you have to integrate, and also including unit tests. So that's really the key message of this talk. So I hope you did get this message. And if you want to start and I whet your appetite, I can recommend you this book, Camel in Action. This is a really good introduction for starting with Apache Camel. And Apache Camel is open source. Everybody can contribute, so it's really great. And so finally, I thank you for your attention. And if you have questions, you can start now. Yes? Exactly, it's a jar library. You can put it into your project. So this is why you can use it in a standalone application or in an application container. It's just a jar you have to add. You can add it via Maven or just as you want.
You had some flow diagrams?
I'm sorry?
You had some flow diagrams? Like representation in
Float?
Flow mode.
What do you want with float? Flow.
Like, can you do it visually? Can all this integration, can we do it visually? Or is it programmatic?
Or is it what?
Like only programmatic, or can we do it visually?
Visually, with tooling, of course, you can do it. So you can do it programmatically with Java or Scala. You can do it declaratively with XML, or you can do it with tooling. For, as I mentioned, there are different vendors. Fusesource, which is bought by Red Hat now, and Talent, for example. They offer GUI builder, so you can create it with visually.
How do you process routes asynchronously? Everything that you mentioned in the presentation about the synchronous calls, right? So if you want to process synchronously, let's say you read the file and you want each line of the file be processed by a different thread. How do you do that?
So you asked if it is how it do it asynchronously or
right. So I want to read the file, each line of the file, and then each line to be processed by multiple threads. How do you do that?
Okay, well, it always depends on every component. So there's specific use cases for every component, and you can configure most of your components how you want to do it. So, for example, also if you have, for example, a file example, and if you have several order items and want to process it differently, there are different enterprise integration patterns which solve this problem. And this is again often one more method call or so. So there's always a use case and solution for every of these problems. So.
Wondering how much overhead the Camel goes.
How much overhead? Okay, that of course, Camel is not much overhead. It always depends on which technologies you want to integrate. So if you use SOAP web services, you have a lot of XML and so on, so that's a problem. But the overhead of Camel is not much, so that's not a problem. In our cases, we used huge processing with file and JMS, and we didn't see any difference between using Camel and not using Camel, so that shouldn't be a problem in normal use cases. Okay, then. from Mule, as I've mentioned, maybe you should also read my blog. I think we have some minutes. I can open other slides. Are there any other questions before? Then I can show you 2 minutes of slides about Mule. Yeah? Okay, the question was when to use an enterprise service bus and when an integration framework. So the integration framework, as you have...
15 minutes.
Okay, so it's no hurry. Thank you. The integration framework is, as you have seen, it's just a little bit of code to integrate your technologies. And an enterprise service bus offers much more features. So, as I said, for example, business process management. So one part of the enterprise service bus is also the integration framework. So several enterprise service buses use integration frameworks inside. So for example, Service Mix and Talent ESB use Apache Camel inside. So the integration framework part is just for the integration. And if you need more, like business process management and monitoring, then you can use an ESB. So it's just more power. But it's also the same functionality of an integration framework, but more. Okay, yeah?
This sort of goes off the topic of cloud services, but what if the components that you're integrating aren't necessarily web services? What if they're local Java method calls? So what if you're all inside the same JVM? Is that still
okay, so
an appropriate use case?
The question was, what if the service is not a cloud service or web service, so it's an internal service or Java or whatever?
Scattered APIs that you have to deal with.
Yeah, though that's also possible. So you don't have to use remote calls or so. There are, for example, as you have seen in the root, there was this bean, and you can use Java beans inside, and there are components. For example, you can use the VM component and so. So it's also not only possible inside one VM, but there's also a component, I don't know the name, where you can use different VMs, virtual machines, and communicate between them. So there are many different components for all of these use cases. So there's no overhead through remote communicating when you have just local calls.
I guess my question wasn't about overhead, but appropriateness.
Yeah, it's also appropriate then, yeah, and yeah. Okay, maybe I can show you 2 minutes about a comparison to Mule and Spring integration because I have slides which compare this. So, where was it? The slides are German, but I hope that's no problem for you. So, there's not much text, though, this I mean. I will just show you some slides of the differences. Okay. So, there are also very similar stuff. As you see here, all have tooling, all are open source. So what about Spring integration first? First, Spring integration has much less adapters, and it's more difficult to create your own adapters because there isn't even a documentation there how you can do it. As I mentioned with Camel or also with Mule, there are archetypes which you can use to create it. And then this difference here is, in my opinion, one of the most important ones. Spring integration and Mule only have an XML DSL. And in my opinion, the Java DSL or programming language DSLs are much better because they have better readability and better support for refactoring and so on. Now here comes the Spring integration guy, I know.
Spring integration has evolved very much in the past few months. There is a Java programming model already, but the documentation is really, really bad.
All right, so maybe it will be improved in the future. So, so I'm no enemy of other frameworks, so it's okay for me. Okay, so let's look, for example, here at this DSL of Spring integration. So we'll compare it to Mule in a moment. So in my opinion, this is no real DSL. It's really tough to read compared to the other ones. So remember the Java DSL, where you know what's happening when you read the Java code. And look at this one. And then I will show you the XML DSL of Mule in a second. Here is Mule. Mule has an advantage compared to Camel. It has several proprietary connectors. So here you have connectors to SAP and TIBCO and PayPal and such stuff. So these are some components which you would have to write with Apache Camel first. But it's only some ones. So It's no support for OSGI in Mule. So if you want to combine it with OSGI, it's not possible with Mule, but with Camel and Spring integration, I think. And the DSL also is only XML. And as you see here, at least this is a real DSL in my opinion. The Camel XML DSL looks almost like this one. So you can read it easily, and this is what I need from a DSL. And remember again the Spring integration DSL, let's go back to it again. In my opinion, this is not as good to read, not easy to read, and so one great thing about these integration frameworks is that you can realize your integration problems easily by modeling and realizing them. And if you look at a DSL and it's tough to read, then it's only half as good, in my opinion. But again, that's my opinion, so yeah.
Can you integrate Camel with Mule or with Spring?
You can, of course, do it, but there's even a Spring integration connector for Camel, but usually it doesn't make any sense because it doesn't make any sense if you have an integration problem if you use two integration frameworks for it. But if you have two applications which both use an integration framework, you can combine them, of course, too. So
yeah, but Mule has a component to integrate to PayPal, so maybe you could use that to integrate to PayPal and then...
Exactly, but you can. The question was if you want to, for example, use the Mule connector for PayPal and another component of Camel. But here I think you are better if you use just one integration framework and write one or two components. Because as you have seen, it's really easy to write a component. For example, PayPal offers a REST API. It's probably 1 day or 2 days to write this component. And if you use two integration frameworks, it's much workarounds and much more effort. So I don't think this makes sense in most use cases. So, okay, so that's it. Thank you for coming. And if you have any feedback, write me Twitter, LinkedIn or so. Thank you.